Okay, so we're going to continue talking about linear systems, two equations with two variables, and solving those linear systems. The difference is that today we're going to be given word problems. And so we're not going to be given the equations to solve. We're going to have to create those equations ourselves and then solve them. This can be a little bit of a challenge, but I think we're up for it. Okay, first example. Says a school group took a field trip to the movies. A total of 30 people went to the movie and spent a total of $114. If the adult tickets were $5 and the children's tickets were $2, how many adults and how many students went to the movie? Okay, so let me just give you a few pointers here. First of all, anytime that you're told totals, most likely those are going to be part of your two equations. Where's the other one? Oh, there it is. So we have a total of 30 people, total of $114. Okay. Now, so I'm thinking that my two equations are going to involve those two totals. Two things are going to add up to those totals. And I have to figure out what is going to add up to those two totals. Well, first of all, the total of 30 people. I know that that's how many people went to this movie. Okay, so then we're looking at the next part, and it's talking about adult tickets cost a certain amount of money and children's tickets cost a certain amount of money. And that is important because of how much total money was spent. That's going to affect it. So let's think of it this way. One of my variables is going to be adult tickets, and we're going to call those A. Then another one of my variables is going to be the child's ticket, and we're going to call that C. Now what we need to do is we need to write two equations based on the totals that we've been given, with the 30 people and then the total amount of money and our new variables. We're going to use those to create the equations. So I know that however many adults went and however many children went, that number added up to 30. So I've got A plus C equals 30. Then my second equation is going to involve my total amount of money, $114. I know that for however many adult tickets were sold, each one cost $5. And then I know however many child tickets were sold, oops, wrote that in the wrong order. Each one cost $2. So 5A plus 2C equals 114. All right, now all I need to do, I've got my two equations written, I just need to solve. I'm going to solve this by elimination. So I'm going to take A plus C equals 30 and multiply that whole equation by a negative 2. That way I can cancel out my C with the second equation. Alright, so I'm going to write that new equation in red underneath this equation right here. Okay, so that's going to be negative 2A minus 2C equals negative 60. Now I'm going to add those two equations together, and that's going to give me 3A, C's cancel out just like I want them to, equals 114 minus 60, which would be 54. Alright, now all I need to do is divide both sides by 3 to solve for A. So A equals 18. Now all I need to do is plug that in to one of my two equations. Oops. I wrote A. I need to write 18 instead of A. So 18 plus C equals 30. Solve for C. C equals 12. Okay. So I have 12 children tickets and 18 adult tickets. Now, for systems of equations, we've been writing all of our answers as ordered pairs. since this is a real world problem, it's not X's and Y's, it's not two lines crossing on a grid, we're going to leave it as this. Okay. Now, next example says Ashley has 21 coins, all dimes and quarters. The total value of her coins is $3.15. How many dimes and how many quarters does Ashley have? Okay, so again, what we're looking for are totals. We know that she has 21 total coins. And again, we have a monetary total of $3.15. So we're going to use those two totals to write our two equations. Equals 21 and equals 3.15. Now, the two things that are unknown to us are the number of dimes and the number of quarters. So, we're going to fill that in the blank. Dimes, D, that's a D, and quarters, let's put that as a Q. Okay, so our two variables, our dimes and quarters, we know have to add up to 21. So we can write that as D plus Q equals 21. And for the second equation, we're just going to put in how much money each one is worth. For every dime that we get, or that we have, that's 10 cents. For every quarter that we have, that's 25 cents added to our total. So just like in the last problem, now it's just a matter of solving. So I'm going to take that first equation and multiply the whole thing by a negative 0.10 or negative 0.1, and then cancel out my d's together. So that's going to be negative 0.10d minus 0.10q equals negative 21 times 0.1 would be minus 2.1. Okay, now I can add those together. Those would cancel out. And that would give me 0.15q equals 3.15 minus 2.1 would be 1.05, $1.05. Now I need to divide both sides by 0.15. I don't have a calculator on me. Let's see, that would be not 8. 8's too big. 6. 6 is too small. 7. 7 times 5 would be 35. 7. So the number of quarters we have is 7. Now I just plug that back in. D plus 7 equals 21. So the number of dimes that I have is 14. I can do a quick check on that to make sure I'm right. 14 dimes times 10 cents would be $1.40. 7 times 0.25, if I have 7 quarters, let's see, that's $1.40. 7 quarters would be $1.175. So I add those up. Sure enough, I get $3.15. All right. Now we are going to spend a little bit of time working in groups. It's one thing to hear your teacher talking through these problems, but it's another thing if you can help each other work these problems out. So I want you guys to work together on this, so since we're working together, it's just going to be me and you. And we're going to try to figure this problem out. It says the perimeter of a rectangle is 46 feet. The length of the garden is 5 feet more than twice the width. Write a system that could be used to find the dimensions of the garden. All right, so we were given another total. It didn't say the word total, but perimeter is a total. It's the total distance around something. We're dealing with a rectangle, so our variables are just going to be length, or L, and width, w. And my first equation, I'm going to make that a capital L, 2L plus 2W equals 46. Then we're going to take the second part here. Let me highlight this in red. The length of the garden is 5 feet more than twice the width. So I can write that as L equals 5 feet more is going to be a plus 5 on the end. It's kind of a turnaround word. Twice the width, 2 times W. Okay. Now, we don't technically have to solve because the equation just says to write a system. But what we will do, we will go ahead and solve that. We're going to substitute that in for L. So it's going to be 2 times length, which is 2W plus 5 plus 2W equals 46. So it's going to be 4W plus 10 plus 2W equals 46. Combine my like terms, it's going to be 6W plus 10 equals 46. If I subtract 10 from both sides, 6W is equal to 36, so W is equal to 6. Now to find my length, I'm just going to plug that in. Length equals 2 times my width, which is 6, plus 5, so my length is 12 plus 5 is 17. And I can double check that to make sure I'm right. If I multiply the length times 2, I get 34. And add that to the width times 2, which is 12. 34 plus 12 gives me 46, which checks out. All right, so in your journals, the assignment was to do this. Write the title Insight. What do you think is the most difficult part of solving the word problems that we did in class today? So when you look at the word problems, what is the hardest thing for you to do? And then I want you to think about what you can do to help yourself be more successful at these word problems. All right, and then I'm going to add in a blank page here, and I'm going to write on that your homework assignment is the worksheet 3.7C, which is a handout that I'm giving out in class, just to make sure we're all clear about what the homework assignment is. All right. So that's pretty much it for solving word problems using linear systems. Come see me if you need any help.